In this video, we're going to have a look at the auxiliary angle formula. So let's consider the function y equals sine x plus cos x and its resulting graph. This simply means adding together the sine and cosine curves to make this new function. So if we go and do that, if we come and look at some of the main features, let's start at negative 180 degrees. If we added the sine and cosine curves together, we would have this resulting point. And as we go through at some of these main features, we can start to graph y equals sine x plus cos x. So I'll just place a few more points in so we can see exactly where it's going to go. So we get a bit of a feel for what this curve actually looks like. So in green, we've got y equals sine x plus cos x. Now, if we consider that graph, it looks very sinusoidal, which means it's like a sine waveform. So essentially, what we could do is try and replicate this just in terms of writing it as a sine graph. But what we can see when we look at this graph is there's only two real changes. That mean line is still running through the center at y equals 0, but we just see an increase in its amplitude. And the only other thing we can notice that it has shifted. It's either shifted to the left from the sine curve, or from the cosine curve, it's shifted to the right. So the only thing that we have as a change is a phase shift. So we're actually going to try and do exactly that. We're just going to focus on the amplitude and a phase shift in using the sine or cosine original curve to rewrite sine x plus cos x. So this is the format we're going to take. We're going to focus on writing it in terms of sine because my leading term here is sine. We're going to call R the amplitude. I'm going to use a capital R. And we're going to use alpha as what we call the auxiliary angle. And that's going to represent the phase shift that is essentially happening. So before we go back and consider sine x plus cos x, let's have a look at this in general terms. Let's consider a times sine x plus b times sine x, and we're going to try and write it in terms of r sine in brackets x plus alpha. So if we focus on that right-hand side using our knowledge of the identities, we can expand sine x plus alpha using our angle sum identity. So I'm going to leave the r out the front. This would be sine x times cos alpha plus cos x times the sine of alpha. And placing r into each of those, I can see that the cos alpha and sine alpha would just be constant. So I'm going to put them next to the r because that's also a constant or coefficient. So we end up with r cos alpha times sine x plus r sine alpha times cos x. And if we relate this to the left-hand side, this is a times the sine of x plus b times the cos of x. So we can clearly see that there's a link between r cos alpha as the coefficient and a, and r sine alpha and b. So let's take a closer look at those. So if a is going to be represented by r times the cos of this angle alpha, and b is going to be represented by r times the sine of this angle alpha, then if we squared both of a and b, this would be represented by r squared times cos of alpha squared plus r squared times sine alpha squared. If we take out that factor of r squared, we're left with cos squared alpha plus sine squared alpha, and knowing the Pythagorean identity, that equals 1. So it tells us that a squared plus b squared is just r squared. what this allows us to do is come up with an equation or formula to work out R, that amplitude of the sin x plus cos x graph. Further to this, using A equaling R cos alpha and B equaling R sin alpha, if we wrote them in terms of cos alpha and sin alpha, we would have A over R for cos alpha and sin alpha would be B over R. What this allows us to consider is how we can work out the value of alpha, that angle. Well, because I've got sin alpha and cos alpha, I'm going to place it sin over cos because I know that this equals tan alpha. And that will simply be B over A, which means that to work out that angle, alpha, that auxiliary angle, it would just be the inverse tan of B over A. So what we've got here, just from using our knowledge of identities, we can work out that R value and the alpha angle if we want to write any form of sine plus cos graph in terms of a singular sine or cos curve. So let's return to our original graph, y equals sin x plus cos x. Here A is worth 1 and B is worth 1. So I'm going to write this in terms of R sin x plus alpha. I'm going to do that because my leading term is a sine, so I'm going to put it in terms of the sine sum identity here. I've worked out now that my R is going to be the square root of 1 squared plus 1 squared, which is the square root of 2. And alpha is going to be the inverse tan of 1 on 1, which we know is going to be pi on 4. So this tells me that this is going to equal square root of 2 times the sine of x plus pi on 4. I know I'm going to use plus in my single curve equation here for sine because I'm dealing with a sin x plus cos x. So let's see this in action again. So let's try and express y equals 4 sin x plus 3 sin x in the form r sin x plus or minus angle alpha. So I know that my r value is going to be the square root of 4 squared plus 3 squared, which is the square root of 25, so r is just 5. And the tan of angle alpha is going to be b over a. Now I'm going to take exactly how it's written left to right. So 4 is going to be my a value and 3 is going to be my b value. This gives me an alpha value of 0.644 radians. So therefore, I know it's going to be 5 times the sine of x plus 0.644. I know I'm going to be using sine because my leading term was sine, and I know it's going to be plus because I know that because I'm dealing with the sine angle sum or difference identity, when I'm dealing with sine plus cos, I know that I'm going to have a plus in my angle identity. So in example 2, we've got y equals 5 cos x plus 12 sin x. So we're going to put this in the form of a cosine curve. So first of all, we're going to find our capital R value, our amplitude of the resulting curve. That's the square root of 5 squared plus 12 squared, which is the square root of 169, which is 13. The tan of alpha is going to be b over a, 12 over 5, which is 1.176 radians. So I know this is going to be in the form of a cosine curve because I'm going to use that leading value here of cos. And oops, I've just missed that amplitude, so let's put that in. So r is 13 times the cos of x. And I know here, because I've got an x, cos x plus sin x, I know my operation here will be to subtract 1.176. Thinking back to the angle sum and difference identity for cosine, so if we've got a subtraction, then it's cos x, cos of the angle plus sine x, sine of the angle. So it's the opposite sign. Okay, so in example 3, we're actually going to focus on this equation that we have just written, this function, and we're going to determine the maximum and minimum values of the function y equals 5 cos x plus 12 sine x. So if we take the fact that we know that this is the same as plotting 13 cos of x, take 1.176. If we think of the transformations that have occurred here, we've got a change in the amplitude, because we've had a vertical dilation. So that tells us from that mean line, which is on the x-axis, this is going to be stretching up to 13 and down to negative 13. And we know that the other change has been a phase shift. So that means it's going to move 1.176 to the right. So we're going to just have that curve happen. But all we want to know is what is the maximum and minimum values of y. So the maximum value of y is going to be 13, and the minimum value of y is negative 13. So now it's your turn to have a go at the following two questions. Express sine x, subtract 2 cos x in the form of a sine curve. And in question 2, is express sine x, take the square root of 3 cos x in the form of a cosine curve. So I've just put 2 hints here just to be aware and perhaps rearrange the format, because at the moment we're starting with a sine x and we want to start with a cos x. That'll help with using the identity that we've got to form this. And also just be aware of the fact that in front of the cos x is negative root 3. So be aware of that negative. You pause the video and come back and check your answers. So looking at our solution for question 1, we have the format in terms of sine, and we're starting with the sine term. So our r value is the square root of 5 with our coefficients of 1 and 2. The tan of alpha is going to be b over a, 2 over 1, which is 1.107 radians. So we've got the square root of 5 times the sine of x subtract 1.107. I know it's going to be a take because in my initial expression I've got sine x subtract 2 cos x. For question 2, I've rearranged it to put the cosine term first, which means we've got negative root 3, so I've taken that negative out the front. So actually I'm dealing with the square root of 3 cos x subtract sine x. So just focusing on that term, that expression, r is 2 and the tan of alpha is 1 on root 3, which gives me an alpha value of pi on 6. So when I write the function, it's y equals negative, because of the negative, 2 cos, and it's going to be x plus pi on 6. And I know it's going to be a plus because I've got a cos subtract sine.